Okay, let's dive in. It feels like everywhere we turn, the conversation about AI is just buzzing.
Absolutely. Super intelligent robots, the singularity, existential risk.
Or the flip side, this utopian future driven by artificial general intelligence. It's really easy to get swept up in that narrative, isn't it?
Yeah, this intense focus on whether large AI models are really intelligent agents.
But what if that whole framing is,
Yeah.
well, fundamentally off? What if we're thinking about these powerful new systems in a way that actually, it prevents us from understanding their real nature and their actual impact on our world right here, right now?
Hmm.
Welcome to the deep dive.
Hmm.
Today, we're grappling with a perspective that challenges that prevalent narrative head on.
That's right. We're stepping away from the AGI hype, maybe thankfully, and digging into a specific source that offers a completely different lens. It's an article published in Science magazine titled Large AI Models Are Cultural and Social Technologies.
Yeah, this paper really made me stop and think.
Me too. It's
No.
quite provocative.
So, our mission in this deep dive, drawing only from the insights presented in this science article, is to unpack the author's core arguments. They propose viewing large models, things like the systems powering chatbots, image generators, all that stuff, not as nascent intelligent agents, but through a, historical and sociological framework. We want to explore why they believe this reframing is so crucial and what it helps us understand about the real challenges and opportunities these systems present today.
Think of this deep dive like us sitting down together, really wrestling with this significant academic paper. We're trying to extract the most important points, understand their implications, and, get a solid grasp of the author's perspective. It's the kind of core understanding you want if you were discussing this text, its arguments, maybe even its potential blind spots with fellow university students who'd also read it.
Exactly. It's less about predicting some distant sci-fi future.
Yeah, much less.
And much more about gaining a clearer understanding of the present reality of these technologies. What are they actually doing now?
And the paper doesn't waste any time getting to its central critique, does it? It immediately addresses what the authors see as the prevailing misconception in the current public discourse around AI.
No, it jumps right in.
Exactly. The paper points out, quite starkly, that much of the debate about AI today, particularly concerning large models, revolves around this question. Are they intelligent? Are they autonomous? Are they truly agents?
Yeah, the whole is it thinking debate.
And this, of course, leads directly to the speculation about artificial general intelligence, which is met with this mix of both enormous excitement and pretty significant anxiety that dominates headlines.
This vision of LMs as these budding minds or autonomous entities, it seems to capture the popular imagination. It's the stuff of science fiction, right? Potentially leading to either utopia or disaster.
Yes, and the authors of this paper look at that prevalent view and argue it's fundamentally misguided. Their critique is sharp. They state unequivocally that this discourse about large models as intelligent agents is fundamentally misconceived. Yeah, they see it as missing the point of what these systems actually are and how they function.
That's a really strong claim. They must have some specific reasons for saying that LMs are fundamentally different from intelligent agents as they currently exist. What are the key distinctions they highlight?
Well, one of the most critical distinctions they draw, which I found particularly insightful, is that these models, at their core, do not possess a conception of truth or falsity.
Ah, okay. No sense of true or false.
Right. They don't have an internal model of reality that they are trying to align with objective truth. They are, the authors emphasize, essentially statistical pattern matchers. That's the key.
Statistical pattern matchers.
This fundamental lack of grasping truth or falsity is, according to the paper, the root cause of problems like hallucinations, which they say are endemic to current large language models.
Right, where they just make stuff up, basically, but sound confident doing it.
Exactly. This is where the model confidently generates output that sounds perfectly plausible, even authoritative, but is factually incorrect. And while, techniques exist to try and mitigate these hallucinations,
Like RLHF and things like that.
yeah, things like that. But the paper argues that the model itself isn't operating from a place of understanding what is true in the world. It's just generating a statistically probable sequence of words or pixels based on its training data.
So they aren't trying to know something in the human sense. They are predicting the most likely next element in a sequence based on patterns learned from massive data sets. It's about statistical correlation. not causal understanding or factual verification.
Precisely. And a point the authors are very clear on is that simply increasing the scale, adding more data, more parameters, more computing power won't fundamentally change this. They state explicitly that scaling won't convert these statistical pattern matchers into intelligent agents with a conception of truth or the kind of world modeling capabilities we associate with true agents.
Huh. So throwing more compute at it doesn't magically create understanding.
That's their argument. It makes me think of that calculator analogy again. You can build a calculator that can do quadrillions of calculations per second, far beyond human speed, but it doesn't suddenly understand the meaning of the numbers or why it's doing the calculations in any sort of, agentic sense.
Yeah, that's a useful way to think about the author's point. Speed isn't understanding.
And they add another layer to this misconception: the interfaces. The fact that we interact with many large models through conversational interfaces, chatbots, creates a powerful illusion of engaging with an agent.
Ah, yeah, because it talks back.
Right. The paper draws fascinating parallels here to how humans have historically created fictional agents, like mythological heroes such as Hercules, or trickster figures like Anansi, even beloved literary characters like Peter Rabbit. We use these agent-like constructs in stories and narratives to convey information and ideas. And similarly, we tend to anthropomorphize complex systems, treating markets or states as if they're agents capable of making decisions, sometimes even granting them legal personhood.
Ah, that's a great point. It's almost a human cognitive bias, isn't it? If something interacts with us in a way that seems coherent or responsive, our brains seem kind of wired to attribute agency to it.
Seems like it.
So a chatbot, designed specifically for conversation, naturally triggers that instinct, making us think of it as a thinking entity rather than, well, a complex statistical process behind a facade.
Exactly. And the authors argue that this tendency to project agency onto LMs, while maybe understandable, obscures their true nature. To counter this misconception and gain accurate understanding, they contend we must combine insights from social and behavioral sciences with computer science.
So it needs that interdisciplinary view.
Yes, this approach, they argue, reveals that LMs are best understood not as intelligent agents, but as a new kind of cultural and social technology.
Okay, that's the core reframing. Shifting from intelligent agent to cultural and social technology. Let's really unpack what they mean by that definition in the context of this paper. What is a cultural and social technology, according to them?
So the paper defines it as a system that enables humans to access, organize, transform, and restructure information accumulated by other humans. That's key information accumulated by other humans.
Okay.
And the ultimate goal or effect of such technologies is to facilitate large-scale human coordination. They even bring in Herbert Simon's terminology, suggesting LMs are a novel variant of artificial systems of human society.
Artificial systems of human society. That phrase really emphasizes the societal function, doesn't it? It's not just about handling information in isolation, but about how that information handling shapes and facilitates how humans interact and coordinate on a large scale.
Precisely. And the authors see LMs as powerful precisely because they combine features of both earlier cultural technologies and earlier social technologies in a novel way.
Okay, so break that down. What kind of earlier cultural technologies are they referring to?
They list really fundamental human innovations like pictures, writing, print, video, and then later, things like internet search.
The ways we record and access stuff.
Exactly. The common thread is that these technologies created new ways for humans to access and engage with information created by others. LMs are fundamentally built upon this legacy. The paper highlights that the foundational prerequisite for LMs is the vast quantity of past human cultural production, text, images, moving images being digitized and made available on the internet in a machine-readable format.
Right, without that massive digital archive.
Exactly. Without that digital availability, LMs as we know them simply wouldn't exist.
Okay, so that's the cultural tech side. What about the social technologies?
But the paper argues LMs aren't just like these cultural technologies, they also share features with earlier social technologies. These aren't passive storage or retrieval systems. They actively reorganize, transform, and restructure information in distinctive ways to facilitate coordination.
The examples are?
The prime examples they give are economic markets and state bureaucracies.
That analogy to markets and bureaucracies is the part that really started shifting my perspective when reading this. It's not just about accessing static information like a library or a search engine index. It's about processing and transforming it dynamically, kind of like how market prices aggregate information or bureaucratic systems categorize populations.
Exactly right. And this leads to the core argument refinement. The paper is not saying LMs simply have cultural and social consequences, like, the steam engine or electricity had profound societal effects after their adoption.
Which they obviously do.
Right. While that's true for any major technology, the author's point is that LMs are themselves a specific type of cultural and social technology, analogous in function and impact to historical systems like print, markets, bureaucracies, or even systems of representative democracy.
Wow. Okay, so the category of technology is different.
That's the claim. And they believe viewing LMs through this historical lens of past cultural and social technologies is key to understanding their actual effects now and in the near future.
Okay, so not the effects of steam, not the hypothetical effects of AGI.
Right. They argue that the consequences we are currently observing and should be anticipating from LMs are markedly different from both of those things, and crucially, distinct from the hypothetical effects of a truly superintelligent AGI.
So reflecting on history is more useful.
Instead, reflecting on the history and dynamics of past cultural and social technologies, they argue, provides a much more useful framework for understanding the perils and promise of large AI models.
So thinking about the impact of the printing press on the spread of ideas or how market systems changed economic coordination might be more relevant to understanding, say, ChatGPT's impact than imagining sentient machines.
That is precisely the argument they make. They suggest that lessons learned from the historical development and societal impact of past cultural and social technologies offer a better guide for navigating the current landscape of LMs than worrying about hypothetical superintelligent agents.
Yeah, okay, that makes sense. Let's spend some time on that historical context then. The paper draws several fascinating parallels. Where do they start?
They begin by emphasizing something quite fundamental, that human evolutionary success is arguably linked to our reliance on culture, starting with language itself, to learn from and build upon the accumulated knowledge and experience of others.
Right, we learn from each other across generations.
Exactly. And major shifts in the technologies that enable this cultural transmission have historically led to profound transformations in human societies.
Like the fundamental transition from oral cultures to those based on writing, that must have been huge.
Exactly. The paper traces this progression from spoken language to the development of pictures, then writing, followed by the printing press, and later film and video. Each innovation created new ways to capture, preserve, and disseminate information.
And systems grew up around them.
Right. And alongside these media, new organizational systems emerged to manage this information. Think libraries, newspapers, eventually internet search. The paper underscores that these weren't just technical shifts, they deeply affected human thought patterns, social organization, and political structures.
The example they give about the 18th century print advances accelerating the spread of ideas feels particularly vivid.
Yeah.
How did they frame that?
It really highlights the transformative power. The paper notes how improvements in printing technology dramatically lowered costs and increased speed, allowing ideas to circulate much more rapidly and widely than ever before.
So knowledge could spread faster and cheaper.
Yeah. This accelerated diffusion of new ways of thinking was, they argue, instrumental in shaping the Enlightenment and played a significant role in the lead-up to the French Revolution. It shows how a change in a cultural technology can have massive, systemic, social, and political effects.
A direct line from tech change to societal upheaval.
That's the connection they draw. And then, jumping forward quite a bit, they point to the digital transformation around the year 2000. Converting vast amounts of text, images, and other media into digital formats fundamentally changed the landscape again.
That felt like such a huge shift at the time, and the paper frames it as foundational for LMs. I remember that transition vividly.
It is. The paper highlights that the ability to transmit information instantly and reproduce it infinitely in digital form created the necessary substrate, the raw material, really upon which LMs could be trained and deployed at scale.
The sea of data they swim in.
Pretty much. But as we discussed, the authors also see LMs as related to social technologies, those systems for large-scale human coordination. And they again reference Herbert Simon's view of social institutions as a kind of technology themselves.
It's still a bit counterintuitive, maybe, to think of a market or a bureaucracy as a technology in the same breath as a printing press or computer. How does the paper elaborate on this? It's not hardware, obviously.
No, it's about the function of these systems in processing and organizing distributed information to enable collective action. The paper leans heavily on Friedrich Hayek's famous argument about the price mechanism in economic markets.
Hayek and the knowledge problem.
Exactly. Hayek saw market prices as incredibly efficient, dynamic summaries of a vast, dispersed body of knowledge about supply, demand, preferences, production costs, everything scattered across an entire economy.
So individual buyers and sellers don't need to know all the complex details. The price itself acts as a signal.
Exactly. It aggregates and transmits that information in a simplified way, allowing coordination without everyone needing the full picture. Hayek viewed the price as a lossy but useful representation.
Lossy but useful. I like that.
Yeah. It doesn't contain all the underlying detail. It's incomplete and uninvertible. But it's incredibly useful for guiding individual actions that collectively result in large-scale economic coordination.
And they draw similar analogies for other social systems.
Right. Similarly, the paper mentions election mechanisms in democracies as a way to focus distributed individual opinions into collective decisions. And they reference anthropologist James Scott's work on how states manage complexity by creating standardized bureaucratic systems for categorizing and managing populations and resources, think censuses, property records, things like that.
Systems of simplification and aggregation.
Exactly. These systems, markets, democracies, bureaucracies, were generating these lossy but highly useful abstract representations long before digital computers existed. A price, an election result, a GDP figure. They all summarize vast amounts of individual knowledge, values, and actions into a simplified form that enables large-scale understanding and coordination.
And the paper points out that while these abstract mechanisms are powerful tools for coordination, they can also profoundly influence individual lives, sometimes with negative consequences, precisely because they simplify things and can create blind spots.
This is a crucial point they make, I think. The paper uses the example of central banks historically focusing on a limited set of economic variables as indicators for financial stability, things like inflation and unemployment.
The standard metric.
Yeah. This simplified representation of the economy, while aiming for stability, meant they paid less attention to other complex areas, like asset markets, specifically housing. This lack of focus allowed instabilities to build up in the housing market,
Leading up to 2008,
contributing significantly to the 2008 global financial crisis. It's a clear example of how focusing on what a system can easily measure or represent can lead to overlooking critical complexities with severe real-world impacts.
because what gets measured gets managed and what doesn't gets ignored.
Kind of. Or the point about markets ignoring externalities like carbon emissions. The price mechanism by itself doesn't represent the cost of pollution unless an external force, like state regulation or a carbon tax, forces that cost to be included and represented in the price signal. These systems are powerful, but their simplified representations can omit crucial information.
It's sobering to think how these powerful, abstracting mechanisms can have such concrete and sometimes devastating real-world effects. They're not neutral.
Absolutely not.
Yeah.
And the paper adds a vital caveat to this whole history. These cultural and social technologies, from language all the way to markets, are only possible because humans possess the capacities of intelligent agents.
Okay. So the tech relies on us.
Yeah. Humans are the ones who can perceive, act, build, and revise models of the world, design goals, create novel beliefs and values, and convey them. These technologies transmit and organize those human beliefs, values, and innovations powerfully, but they don't have meaning or purpose without the underlying human capacity and creativity. Imitation and diffusion, facilitated by the technology, requires original innovation to diffuse in the first place.
That really grounds the discussion. The technologies are amplifiers and organizers of human culture and human coordination, not independent forces generating meaning on their own. They process what we put in.
Precisely. And this brings the paper back to distinguishing current LMs from hypothetical future agentive AI systems. They do acknowledge that, in principle, an artificial system could one day instantiate similar truth-finding abilities and agentive capabilities as human brains.
Like in robotics, maybe.
Yeah, systems used in areas like robotics, which interact physically with the world, might theoretically move towards this. However, they immediately state that, currently, all such systems are very far from possessing these human-level agentic capacities. Their point is that debating those distant possibilities is distinct from understanding the effects of LMs now.
And the reason LMs are the focus now, despite not being agentive in that sense, is the surprising progress they have made through scaling these statistical models.
That's what the paper highlights, the remarkable and surprising progress of large models, which has catapulted them to the center of the public AI conversation and led some people to mistakenly claim that further scaling alone will lead to AGI.
which the authors push back on hard.
Yes, they firmly push back, reiterating their core point. LMs are fundamentally different from intelligent agents, and scaling won't change this.
Because the fundamental flaw, from an agent perspective, remains.
Yeah.
They have no conception of truth or falsity.
Exactly. Which is why hallucinations are an endemic problem, as they put it. They are statistical models predicting patterns, not systems trying to ascertain facts about the world. Large language models analyze massive text datasets, break down words into components, estimate the probability of sequences. This allows them to generate human-like text by predicting the next likely token. Large multimodal models do similar things with images, audio, video.
Just predicting the next pixel or sound based on patterns.
Essentially.
Yeah. So if they aren't agents but statistical models, how do they function as cultural and social technologies in this new way the paper describes? How does that work?
They function, as the paper argues, by combining features of both historical cultural media and social coordination systems. Like library catalogs or search engines, they act as a kind of summary or index of vast cultural corpora.
The access part.
But crucially, they go beyond mere passive summarization. They can reorganize and reconstruct representations or simulations of this information at scale and in novel ways, mirroring the transformative function of markets, states, and bureaucracies.
The lossy but useful representation idea applies here too, then.
Absolutely. The paper adopts Ted Chiang's memorable phrase, calling LMs lossy JPEGs of the data corpora on which they have been trained.
Lossy JPEGs of culture. I like that visual.
They too. They abstract a massive body of human culture, all the text, images, etc. they were trained on, but they do so imperfectly, compressing and losing detail, much like a JPEG image compresses information. But this lossy representation is, paradoxically, what makes them useful for certain tasks at scale.
But they don't just passively reflect the data like a database, or even summarize it like a search result. You said they perform novel operations.
This is key to their power and novelty, according to the paper. They emphasize that LMs enable a wide range of operations on cultural data that were previously either impossible or just too complex and large to handle.
Like what?
Well, they can take existing information and transform it based on prompts, changing the style of writing from academic to poetic, say, or generating entirely new images, songs, or videos from textual descriptions. This capacity to reorganize and reconstruct simulations of cultural information is where their unique capabilities lie.
And the paper makes a critical point, doesn't it? That the success of the latest, most impressive systems isn't purely about the algorithms and the training data. It relies heavily on significant human input beyond the initial training.
Yes, this is vital for understanding how these systems are currently being shaped and fine-tuned. Methods like reinforcement learning from human feedback, or RLHF, are central.
The human preference part.
Exactly. This involves tens of thousands of humans interacting with model outputs and providing ratings and corrections, essentially steering the model's behavior towards desired outcomes based on human judgment and preferences.
And prompt engineering is another example. Users drawing on their own knowledge and ingenuity, experimenting to figure out how to phrase requests to get the most useful output from the model. It's an active process.
Yes, it highlights that the human user isn't just a passive recipient of the model's output. They are actively involved in shaping the interaction. The paper even notes that complex outputs generated by newer chain-of-thought models often originate in dialogue with human users, who provide guidance and structure. The human is deeply embedded in the process.
So, when we interact with a sophisticated chatbot, according to this paper, we're not just talking to a standalone AI. It's more complex.
Much more. The system's apparent capability rests not only on the algorithms, but on the underlying infrastructure, the vast digital libraries of the web, the human coders who built the system, and the global community of active users and annotators who label data and provide feedback.
So it's a whole ecosystem.
Precisely. The paper paints a picture where someone asking a bot for help writing a cover letter isn't just interacting with code. They are, and I quote loosely here, really engaging in a technically mediated relationship with thousands of earlier job applicants and millions of other letter writers, RLHF workers, etc.
Wow. So you're interacting with this compressed ghost of past human effort.
In a way, yes. It's a system built upon layers of accumulated human contribution, filtered and represented through the statistical model.
That really shifts the perspective from thinking about a singular AI entity to seeing it as a complex socio-technical system that remixes human culture.
It does. And this reframing, they argue, is absolutely essential for shifting the debate away from speculative AGI concerns and towards the actual tangible challenges and opportunities these systems create as cultural and social technologies.
Okay, so if we accept this premise that LMs are doing for digital culture what markets did for the economy or print for language, the critical question becomes, what happens next? What kinds of societal impacts should we anticipate and prepare for based on this framework?
Well, the paper immediately points to implications for both economic productivity and distribution, much like any general purpose technology throughout history.
The standard economic impacts.
Right. LMs can significantly complement human work, automating tasks that previously required human cognitive effort. But this efficiency also brings concerns about job displacement, echoing worries from past technological shifts.
Like with scribes or typists.
Exactly. Shifts that automated tasks previously done by human labor, from medieval scribes to 20th century typists and even human computers. Today, that concern is focused on knowledge workers.
But beyond the direct economic displacement, the paper suggests potentially profound and wider cultural consequences, maybe comparable in scale to the transformations driven by print or markets back in the 18th and 19th centuries. That sounds big.
Yes. They note that LMs, like those past technologies, are powerful tools for abstracting and operating on information at a massive scale. And with this power come recurring concerns that have appeared throughout history whenever new, powerful information systems emerge.
Recurring concerns, like what?
We're talking about justified worries about the spread of misinformation and disinformation.
Which we see already.
Definitely. Also, the potential for bias embedded in the training data to be amplified and propagated, and complex questions about cultural homogenization versus fragmentation. These echo historical debates about the printing press, television, or even how bureaucratic or market categories can embed and reinforce existing societal biases and power structures.
It's fascinating how these concerns aren't entirely novel. They are recurring themes associated with technologies that reshape how information flows and is organized. History repeating, maybe?
They certainly seem like recurring themes, but these technologies also historically opened up new possibilities for creativity, knowledge dissemination, and coordination. The paper views the current intense debates over the social, economic, and political consequences of LMs as continuations of these deep historical worries and hopes manifesting in the context of this new technology.
So understanding them requires looking back.
Exactly. Understanding them, the authors argue, requires recognizing these historical commonalities while carefully analyzing the specific ways LMs introduce these dynamics.
And this recognition, they argue, is where the social sciences become indispensable, because they study these kinds of societal shifts.
Exactly. The social sciences arose in part to understand the upheavals of the Industrial Revolution and similar transformations. They are uniquely equipped, the paper suggests, to investigate the complex, sometimes non-obvious consequences of transformative technologies and help us think critically about potential pathways forward and how these systems could be designed or governed differently.
Let's delve into some of those less obvious questions they raise, like the tension between homogenization and fragmentation. It seems contradictory at first glance. How can it do both?
This is a really interesting historical parallel they draw. They connect current debates about LMs to long-standing sociological disagreements about the effects of modern systems like markets and bureaucracies.
Okay.
They cite Max Weber's concern about the deadening, homogenizing consequences of rationalization and bureaucracy in modern life, the worry that standardized systems kind of iron out unique differences.
The iron cage idea.
Right. But in contrast, they mention John Stuart Mill's more optimistic view that market exchanges, what he called due commerce or gentle commerce, would expose people to different ways of life and perspectives, potentially softening conflict and fostering mutual understanding.
How might LMs play out in this tension, according to the paper?
Well, LMs are inherently statistical, right? They are trained to predict the most likely next token or generate outputs that are accurate on average based on the patterns in their vast training data.
Right, based on probability.
This means they are most reliable and effective when dealing with common patterns in data, and less so with rare, novel, or outlier cases. The authors suggest this intrinsic tendency of LMs might reinforce common patterns and perspectives, potentially worsening the kind of homogenization that Weber feared. By making the statistically average more prominent and the less common, the unique, the niche, more obscure or harder to access within the generated outputs.
So they could inadvertently amplify the mainstream and make marginalized voices or niche ideas less visible or accessible. That seems like a plausible risk.
That's a potential risk highlighted by their statistical nature, yeah. However, the paper doesn't end there. They also present a potential counterargument and a significant opportunity. They propose that LMs could be designed and used in ways that actively harness and represent the diversity of cultural perspectives summarized in their training data. Combining and balancing these diverse perspectives, they argue, could actually lead to more sophisticated and robust approaches to problem solving than any single human or traditional system could achieve.
That feels like using the technology to enhance diversity rather than diminish it. How might that look in practice? That sounds ambitious.
Well, one idea they put forward is building what they call society-like ecologies of different LM perspectives or system configurations.
Society-like ecologies.
Yeah. In this model, different LMs, perhaps trained or fine-tuned on different subsets of data or with different objectives, could be set up to debate each other and potentially cross-fertilize, generating new ideas or perspectives that might not emerge from a single monolithic model.
Like a digital parliament of AIs.
Sort of. Or maybe just different specialized tools feeding into each other. This could also help identify gaps or inconsistencies in human knowledge or expertise that current LMs are merely reflecting back at us.
That's a fascinating idea. What else?
They also point out LM's remarkable effectiveness at abstracting subtle, non-obvious patterns from massive data sets of text and images patterns that might be invisible to any individual human observer just looking at the raw data.
Finding needles in haystacks.
Exactly. This capability could be leveraged to find truly novel connections and insights across vast bodies of human knowledge and culture. But they caution that to avoid simply reinforcing average patterns, systems might need to be designed to diversify LM reflections to match the actual richness and distribution of perspectives in human societies, not just amplify the average.
This potential to find hidden patterns and accelerate discovery sounds particularly relevant for research and science.
Absolutely. The paper connects this directly to the historical development of formal science. They note that scientific progress from the 17th and 18th centuries onward relied heavily on cultural technologies like rapid mail systems, scientific journals, coffee houses as meeting places for discussion, and peer review processes.
Yeah, infrastructure of science.
Right. These systems facilitated the sharing, verification, and cumulative building of knowledge. The authors suggest AI technologies have the potential to accelerate scientific discovery even further, but this requires imaginative deployment. Wiring together perspectives across different modalities, text, data, images, even audio, could reveal unprecedented connections.
So instead of just using LMs as sophisticated search engines or assistants that regurgitate existing information, which, let's be honest, is how many people use them now.
Right, that's a common use case. But a more transformative possibility they suggest is to deploy them as maps to explore formerly uncharted territory.
Maps to explore formerly uncharted territory. That metaphor really sticks with me. It's about using them not just to navigate the known landscape of human knowledge, but to help us find what we didn't even realize was there, to push the boundaries of understanding.
Exactly. A tool for discovery, not just retrieval.
Okay, switching gears slightly, the paper also discusses a significant economic tension related to these technologies. The dynamic between those who produce cultural information and those who distribute it. This sounds familiar.
It is. This tension, the paper notes, is inherent in cultural technologies. The creators of content writers, artists, researchers rely on distributors, publishers, platforms, media companies to reach an audience.
And vice versa.
And the distributors need the producers to have something to distribute, but their economic incentives are often misaligned. Distributors want cheap access to content, while producers want their work distributed widely and to be fairly compensated for it.
This tension has certainly been evident in the digital age, with the internet impacting industries like music and news pretty heavily. How do LMs exacerbate it, according to the paper?
The paper argues that the efficiency and global scope of digital distribution already made this tension acute. They point to crises faced by traditional media, like newspapers or academic journals. But the very speed, efficiency, and scope of LMs,
Which can process, remix, generate.
right, generate new content based on vast amounts of training data harvested from human culture, combined with the increasingly centralized ownership of the most powerful LMs. That combination makes this distributional struggle loom especially large.
Ah, the concentration of power. over a technology that can rapidly process and represent the work of countless human producers. That's the key.
Exactly. The author suggests that this concentrated ownership model could allow those who own and control the core LM systems to skim the benefits of efficiency at the expense of others.
Skim the benefits.
Yeah, this could weaken the economic position of the human creators upon whose work the LMs are trained and used, and who often provide the data that continues to train and improve them. Meanwhile, it strengthens the position of those who control the technology, the AI experts and the policymakers who regulate the tech industry.
So it's not just about whether specific jobs disappear. It's about a potential large-scale redistribution of economic power and resources away from content creators and towards the owners and operators of the core AI infrastructure, a structural shift.
Yes, it's fundamentally a distributional struggle over the value generated by cultural information viewed through this historical lens. And the paper critiques framing the AI debate as a simple, inevitable battle between machines and humans, or just a binary choice between Luddite resistance and progress.
Because that misses the point.
That framing, they argue, obscures the true nature of these distributional conflicts, which are not new, and it ignores the fact that there are multiple possible technological paths and choices we could make in designing and deploying these systems. It's not predetermined.
This perspective, grounded in the history of cultural and social technologies and their associated challenges, really points towards the need for solutions that go beyond just technical fixes, doesn't it? It sounds like societal adaptation is needed.
Absolutely. The paper makes a strong case that throughout history, new institutions, both formal regulations and informal norms and practices, emerged to temper the effects of powerful new technologies and manage their societal impacts.
What historical examples of these institutions do they provide to show this pattern?
For the printing press, they mention the emergence of editors, the development of peer review processes in science, and the establishment of libel laws to deal with the potential for widespread defamation. Things we take for granted now, but had to be invented.
Right. And for markets and states?
For markets, democracies, and bureaucracies, they point to things like election law, the creation of deposit insurance to protect bank customers after runs, and institutions like the Securities and Exchange Commission, SEC, to regulate financial markets. They do note that these institutions varied in their effectiveness and often required continuous effort and revision. They weren't perfect solutions.
But a crucial point is that these institutions didn't just magically appear. They had to be built.
Exactly. They were the result of concerted and sustained efforts by actors both within and outside the technologies themselves. This strongly implies that addressing the challenges posed by LMs will require similar, deliberate, multi-stakeholder efforts involving technologists, policymakers, users, creators, civil society, everyone, really.
Which brings us back to their critique of the AGI narrative. They see it not just as inaccurate, but as actively counterproductive because it distracts from these more grounded historical lessons and the real work of building necessary institutions now.
That's a central takeaway. The paper argues that the popular narrative portraying LMs as super-intelligent agents, whether promoted by optimistic boomers or pessimistic doomers within the tech world and beyond, is inaccurate. More significantly, it actively distracts from the actual problems and opportunities LMs present as cultural and social technologies.
So the hype gets in the way of practical solutions.
It hinders our ability, they argue, to draw on historical wisdom to ensure their benefits are maximized and costs minimized.
They really reinforce the idea that LMs, like library card catalogs, the printing press, or the web before them, are part of a long historical lineage of cultural and social technologies. They are not a sudden, unprecedented jump to something totally alien or fully agentic.
Exactly. And this understanding is where, they argue, the social sciences, with their long history of studying technological and societal upheavals, are uniquely valuable. They can provide crucial context and lessons from similar transformative periods in the past.
So how can computer science and social science effectively collaborate on this, according to the paper? What does that look like?
Well, the paper argues that close cooperation between these fields is essential for accurate understanding and effective solutions. Computer scientists and engineers bring the indispensable understanding of how these systems are built and function technically, the nuts and bolts.
You need that technical knowledge.
Absolutely. But social scientists, on the other hand, bring deep knowledge of how past large-scale technologies and systems have reshaped societies, economies, and political landscapes. They bring the historical and societal context.
And they suggest this interdisciplinary approach helps avoid past pitfalls, like misunderstandings between the fields.
Yeah, computer scientists might oversimplify complex social phenomena they don't fully understand, while social scientists might critique technologies without fully grasping their technical capabilities and limitations. By viewing LMs through the shared lens of cultural social technology, both fields have a more effective common ground for collaboration, the paper suggests.
And this shift in perspective has direct implications for how we should approach policy and governance of these technologies, presumably.
It absolutely does. It moves policy discussions away from what they characterize as simplistic battles between the existential fear of a machine takeover and the promise of a near future paradise. The actual policy challenges are more nuanced and grounded in historical patterns.
Okay, like what?
Like markets and bureaucracies before them, LMs will inevitably make certain kinds of knowledge more visible and tractable, typically, the information that can be easily digitized, processed, and represented by the technology. The paper warns that this visibility bias risks policymakers focusing only on what the technology makes easily measurable or visible.
Potentially neglecting other crucial, less tangible factors, like
Wow.
the 2008 crisis example again.
Exactly. And as we discussed with the distributional struggles, this visibility bias can also shift power.
Right, towards those who control the tech.
Yes. Reflecting historical precedents with markets and media, power and influence tend to shift towards those who are best equipped to understand, control, and effectively deploy these powerful new technologies. The paper explicitly states that AI in its current form risks weakening the position of those upon whom it is used and who provide its data, strengthening AI experts and policymakers, unless deliberate countermeasures are taken.
So policy needs to be aware of those power shifts.
Critically aware. Finally, the paper argues that this cultural social technology lens should also reshape the practice of AI development itself. It's not just for policymakers or academics.
How so? What should engineers be thinking about differently?
They believe AI engineers and computer scientists who are already wrestling with important issues like technical bias, algorithmic ethics, and fairness need to go deeper. They need to systematically incorporate social science-informed questions into their work, not just treat them as afterthoughts or purely ethical constraints.
Questions like,
Questions like, how will the specific design choices in a model or system affect the distribution of resources or opportunities in society? The classic who gets what question.
the political economy of algorithms.
Basically. Also, what will be the practical consequences of these systems for societal polarization or integration? Can they be actively designed to enhance human creativity and critical thinking, rather than potentially making us more passive or reliant?
Big, complex questions.
Very. And finding practical, effective answers to these profound questions requires integrating social science understanding alongside traditional engineering goals, like accuracy or efficiency.
And in the author's view, shifting the fundamental debate about AI away from viewing LMs as agents and toward understanding them as complex cultural and social technologies embedded in historical patterns is the absolutely crucial first step.
That's what they frame as the prerequisite. It's the crucial first step toward fostering the necessary cross-disciplinary understanding and action to grapple with their real, present, and near-future impacts.
Okay, so pulling back from this deep dive into the science paper, the core argument is a powerful reframing. Large language models aren't mysterious, nascent intelligent agents on the cusp of AGI. They are sophisticated statistical tools for organizing and transforming human culture and facilitating large-scale coordination, fundamentally analogous to historical technologies like the printing press or economic markets.
And accepting this framework, as the paper compellingly argues, allows us to move beyond distracting speculation about hypothetical superintelligence. It empowers us, maybe, to ask more relevant, grounded questions about the real-world impacts of LMs right now.
And crucially, drawing lessons from history.
Yes, drawing crucial lessons from history about managing powerful information and coordination systems and addressing their inevitable social and economic consequences.
It really does change how you look at the AI tools you might use every day. It's not about interacting with a nascent mind, but understanding that you're engaging with a complex socio-technical system built upon vast amounts of human effort and data, functioning as a new, incredibly powerful iteration of tools humanity's been developing for centuries to manage information and coordinate at scale.
Which leaves us with a significant question to ponder, doesn't it? One that feels particularly pressing after engaging with this paper's perspective. If LMs are indeed akin to historical cultural technologies that profoundly reshaped society, redistributed power, and presented complex challenges requiring the creation of new institutions and the navigation of distributional struggles, how can we, drawing on history's often difficult lessons, actively and deliberately shape these technologies?
How do we avoid the downsides this time?
Right. How do we move beyond just the technical fixes to engage in the messy, essential work of building the norms, the regulations, the institutions necessary to ensure LMs benefit a wider range of people, mitigate bias, counteract homogenization, and avoid repeating or maybe even exacerbating past mistakes of inequality? It seems the real work is societal, not just technological. That's the challenge this paper leaves us with.